it did actually give a really good idea. I mean, it showed that my friend's house, which was down here, actually didn't have bad damage in that area, so it's actually good. Probably the best known crowdsourcing initiative in the geospatial area now is something called OpenStreetMap. This is kind of like Wikipedia for maps, so the idea is you have a map of the world and anybody can go and edit any part of it at any time. Again, it's the same kind of question when you first hear, you think, well, is that going to be accurate? But the whole point is that the community keeps an eye on and polices that. So I first became more aware of this. I kind of heard of it, but I looked at it in more detail late 2007 when it was announced that Oxford University was switching to using OpenStreetMap instead of Google on their website. And one of the main reasons for that is that they, if you look on the right-hand map, there's quite a bit more in the way of footpaths and alleyways on the OpenStreetMap, and that's important in Oxford because it's kind of, there are lots of these little alleyways that people can walk down. And then, so I posted that on my blog around that time, and then 18 months later somebody commented on my blog and said you should really go and look at the OpenStreetMap for Oxford now. And so if you bring that in, you can see there's hugely more detail. There's all kinds of building outlines, there's all the pubs marked by beer glasses there, the things that are important to students. So the community can put on the map what's important to them, you see. And then if you look at the Google map at the same time, it's really basically the same as it was. You can see super clearly there, but it really hasn't changed, just the representation of the bus stop information has changed very slightly. But so an important realisation I got from this was, when I first saw this, I thought, well, that's great, it's going to be a cheaper source of information, as in it's going to be free, but it's not going to be such good quality as you get from traditional sources. But I think this and other examples illustrate that in a lot of situations you can actually get data that is better quality if you have a community that's engaged, and certainly data that's much more up to date. When you find with OpenStreetMap, if it's on the news that a bridge collapsed or something, within a few minutes that bridge is marked as no longer there on OpenStreetMap, and then different maps tend to cache it, so it might take from minutes to hours to a couple of days to be reflected. But that's compared to a traditional process where it probably takes 6 to 12 months to be updated by a Navtech or a teleatlas or those traditional vendors. So OpenStreetMap has amazing momentum. It's well over 300,000 users now. This is one of these numbers that changes every time I do a presentation, so I've switched to just doing round numbers now. Of course, everyone from a traditional geo background is still going to ask the question, what about quality? This guy, Dr. Mickey Hackplay, has done some interesting studies, and I have the presentation online, you can get the links from there, but he compared Ordnance Survey data from the UK with OpenStreetMap data, and basically concluded that the quality was very good, very usable for sort of medium-scale applications, the kind of thing where you might use Google Maps. And several big companies are making a bet on OpenStreetMap. So a few months back, MapQuest announced that they were making a major commitment to OpenStreetMap. They have launched a parallel site, so their main site still uses data from teleatlas or Navtech, one of the big traditional providers. But they have an open map site now that uses data from OpenStreetMap, so it's parallel right now. They've announced a fund of $1 million to help grow OpenStreetMap in the US, where it's not as far along as it is in many other places. And then just in the past couple of weeks, Microsoft has made an announcement that they're making a big commitment to OpenStreetMap too. And they actually have hired the founder of OpenStreetMap, Steve Coast, who's quite a good friend of mine. Actually, he's a fellow Brit, who's been living in Denver, but has just moved off to Seattle. So both MapQuest and Microsoft are getting very committed to OpenStreetMap. But one of the reasons this is so important is one of the big traditional issues for geospatial applications has just been the sheer cost of capturing and maintaining data, whether it's street data or whether it's utility data. And so the important number from this chart is that Navtech, last year they were a public company, said that they spent $400 million on maintaining that street database. And nearly all of that is labour costs. So if suddenly your labour cost goes to zero, then that obviously dramatically changes the economics of everything. And that's always been a challenge for us in the geospatial industry, is we've had to put a lot of effort into justifying projects just because the data creation and maintenance costs are so large. So, how can we apply this back in the utility telecom world? I mean, certainly there are scenarios where you might be able to use OpenStreetMap and things like that. Like I said, we can use public input for helping with reporting problems But I think another big area is really enabling more people in your organisation to easily update data, especially field workers. So traditionally we've tended to think, oh, updating maps is too specialised and those guys in the field don't have the skills. But I think these kind of projects have shown that you can have untrained people, and especially if they have an interest in the data, which your field workers certainly should do, if you give them the right simple tools to update data directly, then you can potentially very quickly increase the quality of the data. So I think that's an area that's very much worth looking at. So I do think crowdsourcing can be a sort of paradigm shift for the way we create and maintain data. We just need to figure out the right places to take advantage of it, and where you still need more traditional approaches. So the final section I'll talk about a little bit is running in the cloud. And so by this I mean basically taking your applications and running them on infrastructure from people like Google or Amazon. That's as distinct from this kind of cloud, which is the clouds over the Adelaide Oval, which are not quite enough to save you guys, almost were. Don't know how that's. So anyway, back to the other kind of cloud. Just for motivation as to why you might want to do this kind of thing, this is an old Google data set from 2005, which was actually the first year Google had their own data centers. They outsourced it before that. And so this is all that they publicly published about what the data centers look like. So they're probably very dramatically different and improved. I mean, 5 years is a heck of a long time in internet years. So anyway, but this is what they look like back in 2005. They have these sort of picture there, and each of those containers holds about 1,000 servers. So this particular facility holds an estimated 150,000 servers, and worldwide Google is estimated to have about 1 million servers. Again, nobody knows that many secrets of that. A lot of people try and guess at it. They do 3 billion searches every day. That's 35,000 searches per second. Deliver 2 billion videos per day. They have 100 million monthly users on Google Maps for mobile. So just really a phenomenal scale. So if it comes to and then they have roughly a zillion times more computer science PhDs than any of our organisations do. So if it sort of comes to a battle between Google and Amazon and those kind of folks in your IT department, that's a little bit what the odds look like. So no offence to anybody in the IT department, but it's really just a matter of the scale of operations. So if you can take advantage of that, those economies of scale, you really can save enormously on the costs of computing, and that's why we're seeing such great focus on cloud computing across the board right now. And I'll just put a couple of examples in here. Obviously, you have to look at your own specific situation, but I think these numbers might surprise some of you. So Amazon does one kind of cloud infrastructure where basically you can sort of rent machines from them by the hour, so you can specify do I want the standard machine or one with extra memory or extra processing. But you can just then go to their website, type something in, or make a web service call, and within a minute or two you have a machine up and running with the operating system that you requested and the software that you requested. They have various standard choices, Windows or SQL Server or whatever. But you can create your own machine images with your specific software on. And so then you get charged by the hour. So here you can see the hourly rates for a standard machine. For a Linux machine, it's 8.5 cents an hour, or for a Windows machine, it's 12 cents an hour. So say you've got some huge processing job that you really need to get done by tomorrow, you could boot up 10 Windows machines within a couple of minutes. That's going to be $1.20 an hour. Run them for 10 hours overnight, that's $12 to get in some enormous processing power, rather than going around and trying to scrounge up extra machines or buying them just for a short-term project. So really a lot of interesting benefits from Amazon. And this kind of thing is great for websites as well, especially when you have demand that varies during certain times of the day. You can add in extra servers, just pay while you're using them, and then take them down again. There's a lot of ways to kind of automatically do that. So that's what Amazon offers, and so that's a pretty good solution if you have existing specific software that you want to run. Google does things slightly differently, and they have what people sometimes call platform as a service, a thing called Google App Engine. And this is what we've been using for the My World development that I showed you before. And the way that this works is you can choose one of two languages, either Python or Java, and then sort of use all Google's infrastructure. So they have their database at the back end, the same database they use to power their search, so obviously it's incredibly scalable. And then the same technology they use to scale up to multiple servers. So you just write your code in Python and upload it, and that's all you have to do, and then that application can basically support 1 million users. Google will scale up to as many servers as you need behind the scenes without you having to know anything. And again, the numbers are kind of amazing in terms of the capabilities that you get. So the way that this works is you get a certain quota for free, but then you can specify a maximum quota per day. So at the moment, my app engine is set up saying I want to spend a maximum of $5 per day. And so for that, if I use the maximum $5, I would get 46.5 CPU hours and 43 million web requests. And I don't know about you, but that seems a pretty good deal to me. And so during the whole, or the first 4 or 5 months of development of my world, my total server cost was 13 cents. It was every day we were under the free limit, except for one day when we uploaded quite a lot of data and did a lot of spatial indexing. And and that's just a small system. It's 2 developers and a few testers now and then. But even for that, I mean, think about what you spend installing and maintaining development systems in-house. So certainly if you're looking at web development, you should really think about running these kind of cloud environments. It's incredibly but still, I get this sort of panic-stricken reaction when I talk to a lot of people about the cloud. Of, oh, well, that's great, but it isn't secure. And there's a fairly long discussion in the interest of time today. I'm not going to get into that in a whole lot of detail, but I mean, my short answer is I think there's a strong argument that your data is actually more secure in the cloud than in a lot of traditional in-house implementations. I'll just mention a couple of things. I mean, one is Salesforce.com is really the sort of poster child for illustration that you definitely can do secure applications in the cloud. I don't know if you're all familiar with it, but I know my company uses it, We Do IT uses it, all kinds of 14,000 companies use it. So Salesforce basically lets you put your sales information in. There's all kinds of confidential information about your customers, what you think you're going to sell to them, how much you're forecasting that you're going to make from them. And yet all these competitive big companies have their data stored in the same database from the same vendor, and Salesforce has been one of the fastest growing tech companies over the past couple of years, being incredibly successful. So clearly you can run things very securely. And then if you do look at cases where there have been data leaks, they're almost always to do with loss or theft of physical media. So the whole WikiLeaks thing was because all the data was on a USB stick. And in typical cloud installation, there is no way to get your data onto the USB stick. I mean, you control it much more carefully. Whereas if you have people with direct access to the physical servers, there's more chance of getting a CD or USB stick. Another reason for us, from a software vendor perspective, is just agility. So Michael Jones from Google likes to say that Google Maps had 400 releases in its first 4 years. Now, a lot of those are bug fix releases, but nevertheless, that's an incredible number. It's 2 releases per week, and they have added a lot of new functionality in there. Whereas in a more traditional enterprise environment, the mature vendors like Small World and Intergraph and Esri are probably on 18-month release cycles, and then most customers take another year, 2 years to upgrade because it's these complex integrated systems and so on. So, all valid reasons, but it basically means that in that kind of environment, it's 4 or 5 years often between a developer making an enhancement and you getting the benefit of that. And technology is moving so fast that you're really losing out on a lot of benefits if there's that much delay, whereas in this kind of cloud